Hello everyone, today I want to talk about the introduction of optical emission spectrum. The optical emission spectrum or OES stands as a pivotal instrument in analytical chemistry, offering a powerful means to unravel the element composition of diverse materials. Operating on the principle of optical emission spectroscopy, this apparatus facilitates the precise identification and qualification of elements within a sample by ensuring the characteristic of wavelength of emitted light. Widely utilized in metallurgy, environmental analysis, and materials science, the OES plays a crucial role in ensuring the quality and compliance of material in various industries. With its ability to deliver rapid and accurate results, the optical emission spectrometer remains an indispensable tool for researchers and professionals engaged in elemental analysis and material characterization.
Hello everyone, my name is Uma Akira and I will present to you about the history of OES. To begin with, in the 19th century, scientists such as Gustav Kirchhoff and Robert Bunsen contributed to the discovery of elements that emit and absorb light at a specific wavelength. And in the early 20s, spark or flame emission spectroscopy is used as a technique to test the elemental composition of materials by using electrical sparks to excite atoms. Moving on, in the 1920s, spark spectroscopy was further developed into arc spark spectroscopy, which uses two electrodes, ensuring a more stable and intense light emission. The development of ICP in the 1960s was introduced to replace the use of flame emission spectroscopy, as it was not very sensitive and has a lot of interference issues. Between the years of 1980s to 1990s, the advancement in electronics, optics, and computer technology contributed to the evolution of OES, which is more advanced in resolution, sensitivity, and automation. Over the years, the development of CCDs and PMTs further enhanced the sensitivity and speed of the OES. Now, OES can be divided into two types, which are the ICP OES and also arc spark OES. There are 6 working principles of OES in total, and we'll start off with the preparation of sample. Basically, the samples used are typically in the form of solid, liquid, and gas, and usually the solid needs to be in a thin film or be processed into a powdered form. Next is the excitation of atoms and ions, in which the sample is introduced to high energy sources so that it can excite the atoms or ions. Next, moving on to the emission of light, the movement of excited atoms or ions to higher energy states will slowly return to their ground state, releasing energy in the form of light. This will subsequently produce specific wavelength which can show what elements are present in the sample. Next is the light collection and dispersion. The emitted light is collected through a system of lenses and mirrors and directed towards the prism called spectrometer. So this spectrometer then disperses the light and the wavelength are collected. The fifth one is the wavelength selection, in which a monochromator is used to separate specific wavelengths and emit light from different elements for accurate analysis. Lastly, detection and data analysis. A photodetector such as CCD or PMTs are used to capture and measure the intensity of emitted light at specific wavelength, and this therefore shows the intensity of light and concentration of the element present in the sample.
Hello everyone, my name is Woon Yao Lee and my matrix number is AM230133. Today I'm going to continue the next part, which was the purposes and testing process. So there are 4 purposes on why we use the optical emission spectrometer, which I call it as OES machine. And the first purpose is to trace metal analysis to determine the chemical composition. Next, It's also used for qualitative and quantitative elemental analysis of materials. The third one is used for identifying new materials, and the last one is used to analyze the composition of metals and alloys. So the ICP-OES instrument works by exciting atoms or ions using an argon plasma. Next, it is also used to measure the intensity of light emitted when the electrons in the atoms or ions return to the ground state or a lower energy state. The last one is by calculating the concentration of specific elements in a solution based on the calibration graph. So there are 8 steps of testing process when using the OES machine. The first one is the sample preparation, where the representative samples of the materials are collected and the samples are cleaned so that they are free from contaminants. The next one is the calibration step. The OES instrument is calibrated using certified reference materials with known elemental compositions. After that, they establish a calibration curve to relate both intensity of emission lines and concentration of each element. The third step is the instrument warm-up. The OES instrument is allowed to warm up so that it can stabilize its component for consistent performance. Next one is the sample loading test. After the samples are loaded onto the sample stage of the spectrometer, the position of the samples is adjusted so that it can optimize the signal intensity and ensure representative analysis. The fifth step is the selection of analytical parameters. After the steps above are done, they choose appropriate analytical parameters such as wavelength range, time, resolution, based in the element of interest and expected concentrations. The sixth step is the emission spectra association. Firstly, initiate the analysis to generate emission spectra from the excited atoms or ions in the sample. Record the intensity characteristic emission lines for each element. The seventh step is the data processing. The raw data is processed to identify quantify the elements present in the samples. If possible, apply correction factors and background solution to enhance accuracy. The last step is quality control checks. We apply quality control check by analyzing standard reference materials and control samples. Be sure to verify the accuracy and precision of the instrument by checking against known values. Next one, I'm going to explain on how to analyze the results obtained from the instrument. So there are 2 aspects that we're going to discuss. First one is the instrument that needed and the function to operate optical emission spectrometer, or we call it as OES. The next one, we will also discuss about other ways on how to analyze the result from the instrument. So there are 6 instrument users in this OES machine. The first one is the nebulizer. The nebulizer turns the liquid into a fine aerosol using a stream of argon gas. This aerosol passes into the spray chamber where the larger droplets are removed from the aerosol. The rest of the aerosol continues into the plasma torch. The next part is the plasma torch. The plasma torch consists of 3 concentric glass tubes. The argon gas flows between 2 outermost tubes, and the electric current is passed through the metal coil around the glass torch. This will create a magnetic field and the current. The third instrument is the radio frequency generator, or we call it as RF generator. It is a box of electronics that generates the radio frequency energy that passes through the metal coils around the plasma torch. If there are only low concentrations of elements in the sample, the RF power might need to be increased while the flow of the sample into the torch is decreased. The fourth instrument is the optical spectrometer. So as the excited electrons return to a lower energy level, light at a very specific wavelength is emitted, and this depending on the element and the energy level. If there are many different atoms in the sample, then light at many different wavelengths will be emitted. And we're going to the next part, which was the detector. The surface of the chip is divided into pixels, each of which measure the photons of light of a different wavelength. After that, we go to the last part. It was the specialized instrument control software. It calculates the concentration of each element in the sample and use the calibration performed before the sample analysis. Next, I'm going to discuss about analysis based on results. So there are 11 steps of how the analysis can be done based on the results produced by the OES machine. The first step is the identification of peaks. Firstly, we examine the emission spectra generated by the OES for characteristic peaks associated with different elements. Next step is the peak integration. We measure the intensity or area under each peak to quantify the amount of each element present. Integration of peak areas provides a quantitative measure of the elemental concentrations. The third step is the calibration curve. Use the calibration curve established during the calibration process to relate the measured intensity or peak area to the concentration of each element. Calibrate the instrument response to obtain accurate and reliable concentration values. The fourth step is the background correction. Apply background correction to eliminate any interference or background noise in the spectra. This correction helps improve the accuracy of the elemental analysis. The fifth step is the matrix effects consideration. But we need to consider and correct for the matrix effects if the composition of the sample matrix affects the accuracy of the results. The sixth step is the comparison with standards. We need to verify the accuracy and reliability of the analysis by ensuring that the measured values are within an acceptable range of the certified values. The seventh step is the quality control checks. Same thing, we need to perform quality control checks using control samples to assess the precision and repeatability of the analysis. Evaluate the stability and performance of the OES instrument over time. The eighth step is the statistical analysis. If needed, we need to apply statistical analysis to assess the variability and confidence interval of the results. The next step is the data interpretation. We need to interpret the result in terms of materials elemental composition. Then we need to consider the context of the analysis and the specific requirements or standard relevant to the application. The next step is reporting. We need to generate a comprehensive report that includes details such as sample identification, elemental concentrations, uncertainties, and any relevant information about the analysis. The last step is the troubleshooting. Let's say if there are problems and issues come, need to investigate and address any unexpected results or issues during the analysis process. Determine the root cause of any discrepancies and take corrective actions if needed. So now I will pass to the next part to my other friends. Thank you.
The Optical Emission Spectrometer or OES serve a critical role in current and future industrial activities across a various sectors. First, in manufacturing and production. Processes monitoring. The OES enable the real-time monitoring of manufacturing processes, ensuring the consistency and identifying any deviation in elemental composition that might affect the final product quality. It also traces the elemental analysis. Industries, especially in electronic, benefit from OES in detecting trace elemental critical for product performance and reliability. Secondly, it also helps in environmental analysis. In pollution control, the OES plays a vital role in environmental monitoring by analyzing the air, water and soil samples. It aids in identifying quality pollutants, support industries in adhering to environmental regulations. It also helps in waste characterization. The OES assists in characterizing industrial waste, helping companies manage and dispose of material responsibility. In pharmaceutical and biotechnology, The raw material analysis in pharmaceutical manufacturing OES ensure the purity and quality of raw materials, contributing to the production of safe and effective medicine. The OES also beneficial in food and beverage industry. The quality assurance. The OES assists in ensuring the elemental composition of food and beverages, supporting quality assurance and compliance with safety standards. It also helps in mining and exploration. In mineral analysis, the OES is employed in mining for rapid elemental analysis of ores, providing valuable insights for exploration, extraction, and processes activities. Lastly, it also beneficial in research and development. Material characterization. The OES contributes to the development of new materials by characterizing their elemental composition, helping researchers to understand the optimized material properties. In innovation process, ongoing advancement in OES technology support innovation in industrial processes, enabling more efficient and sustainable manufacturing practices. That's all from my team. Thank you.